Hello everyone. So today we will discuss about the logistic regression. Logistic regression is a type of machine learning algorithm used for classification task. It is used to predict the probability of an outcome that can fall into one of two categories: binary classification like yes no, 0 1 or true false. Despite its name, it is a classification algorithm, not a regression algorithm. Now we will discuss about the key concepts of logistic regression. Binary outcome. It predicts the probability that an instance belongs to one of two classes. Example 0 or 1, spam or not spam, disease or no disease. Sigmoid function. Logistic regression uses the sigmoid function, also called the logistic function, to output values between 0 and 1. This is useful for making probability predictions. And sigmoid function is equal to fx equal to 1 upon 1 plus e to the power minus x, where x is the input variable and y is the output variable. In this figure, the dependent variable y will have only values between the 1 and 0. So this is the diagram of a logistic regression. Now, moving forward, we will see logistic regression using a Python. So first we have imported some libraries, like we have import numpy as np, import pandas as pd, we have import numpys and pandas for data manipulation, and we have also imported train test split, logistic regression, standard scalar, accuracy score, classification report, confusion matrix, and load arrays from the sklearn model, which helps provides the machine learning tools. Now we will load the arrays dataset. So firstly we will load the arrays dataset using this load arrays function. Now we will combine the features and target into the data frame for easier handling and name the columns. We will name the columns using this line. Now consider only two classes for binary classification, class 0 versus others. Now we will convert the target variable so that class 0 is labeled as 0 and all other class are labeled as 0. We will now separate the features x and y by this line of codes. Now we will split the data into the training and testing sets. So we will split our data set into the training and testing set. 80% of data will be in the training set and 20% will be in the testing set. Now standardize the features. Now we will standardize the features using these three lines of a code, so they have the same scale, which helps improve a model performance. Now we will create a logistic regression model that will be used for classification, and logistic regression function is used for creating that model. Now fit the model on the training data. Now we use a model.fit, which contains two parameters, x train scaled and y train, to fit the model. This do the test on the training data. Now make prediction on the test set. To make the predictions on the test set, we use a predict method. Y predict is equal to model.predict x test scaled. This is the parameter here. And we will train the logistic regression model using the training data. Now to evaluate the model performance, we will use the accuracy, confusion matrix and classification report. For accuracy, we will use the accuracy score. And confusion matrix, we will use this confusion matrix function which have two parameters, y test and y predict. Classification report, for classification report we will use a classification report function which also have a two parameters, y test and y predict. And this report gives us with the precision, recall, f1 score and following. Now we have find these values, then we will print this values using the print function. And after running this following code, with the help of this icon, we will get the following output, where accuracy is equal to 1.0 and confusion matrix is 2 into 2 matrix, where the values are as follows, and classification report gives us the precision, recall, f1 score, support. So this was all about the logistic regression.